Hey everyone! Welcome to the PVS Studio channel. Today, we're talking about embedded development, how it differs from regular development, and how static analysis can help. First, let's find out what embedded development is. If you look up the word embedded in a dictionary, you'll get something like fixed into the surface of something. Well, that's not really helping. And there's one good reason for that. Today, we can say embedded when talking about any device that contains and executes program code. For example, my fitness tracker, the camera filming this video, a car's dashboard, and internal components. And the list could be infinite. Even bulbs are smart now. Now, it's time to find out how embedded development differs from other types of software development. Suppose you decide to delve into the world of embedded development. The first distinction, you can't download your favorite IDE and start creating. At least you need some device for which you're going to write software. I won't give any tips to expert developers because, well, they're called experts for a good reason and know everything already. If you are a beginner though, I recommend you look into Arduino platform compatible controllers, Nano, ESP, or something of STM32. And here's a little tip: buy several controllers at once. Why? Because we are proceeding to the second distinction. With your program, or with your hands, you can literally destroy a device. Wrongly applied voltage burn down a controller? Classic. Can't upgrade firmware because of the incorrect settings? Typical. Anyway, let's not talk about sad things. I'd rather tell you the third distinction. Sooner or later, you'll encounter the limited resources when developing software for microcontrollers. For example, the Atmega 328 microcontroller is the most widely used one. Let's see what we can get for $2. Well, not that much. An 8-bit processor with a clock speed of up to 16 MHz, 2 KB of RAM, and about 30 KB to store your program code. Not so much compared to the development for classic platforms, is it? But there's more to this. In commercial development, you have to seek out the ways to optimize things so that you can use minimum required controller. You might say, oh, come on, microcontrollers are not so expensive. A couple of cents more, a couple of cents less, a developer's time is more expensive. This is not quite so. You should keep in mind that your device can be produced in huge amounts. In this case, we deal with the serious money. The fourth, and probably the nastiest distinction, is that with embedded development you can't fix the release software. This strongly depends on product specificity, but I could not help but mention it. Now we see progress on this issue in some areas, but modern apps on smartphones are still inconvenient. And now you're wondering, wait, what does this have to do with static analysis? We're kind of watching the PVS Studio channel here. Don't tell me you're not getting this. The last 2 points prove that static analysis can help with embedded development. I guess many of you saw the similar graphs. The later you notice the error, the more expensive and difficult it is to fix. Well, for embedded development, this graph is slightly different. Software vendors can't always fix the error. In this case, they have two options: to recall faulty software or to put their reputation on the line. Yeah, later on, developers can release an updated device. However, the users who have already tried a flawed product are unlikely to use it again. I think it will be great to check some embedded projects and make a couple more videos about them. Maybe we'll check some popular libraries or something bigger. In any case, video content depends only on you. So don't forget to like the video and subscribe to our channel. That's all for today. Have clean code.